In this video, I'm going to go over the general strategy for solving optimization problems. So what makes optimization problems so difficult is that every problem is different. However, there's a general strategy to use for every single problem that will help you to work your way through that particular problem. And so here's the procedure. Number one, identify the objective function. Well, the objective function is that function that you want to actually optimize. In this example down here, that would be p equals 16xy. Then identify the constraint equation. The constraint equation will be some other equation that relates the two variables in the objective function. So in the objective function, we have an x and a y, and here we have another equation that shows how x and y are related. X plus y equals 6. So this is the objective function, and this is the constraint. That's the first thing that you need to do. Now keep in mind that not every problem will have a constraint, but most will. The third thing that you want to do is to substitute the constraint equation into the objective function. And I'll show you that when we work through the problem. And then optimize the objective function. So when I say optimize the objective function, that is what we have already learned how to do. That's the procedure that you learn for finding your extreme values. So you find the first derivative, you set it equal to 0, you find your critical points, and then you test to see if those critical points are relative max or mins using the first or second derivative tests. Okay, let's do this problem using these 4 steps. So I've already done step 1 and 2. I know that the objective function is p equals 16xy and that the constraint is x plus y equals 6. So step 3 says to substitute the constraint into the objective function. So that's what I'm going to do. I'm going to say p equals 16x. Wow, this is not writing well. Let's try the other side of the pen. So p equals 16xy is my objective function. Well, the first thing that we need to do is take the constraint and solve it for one of the variables. So let's solve that for x. X would then be equal to 6 minus y. Now we're going to take that and substitute it in here for x. So now p is equal to 16 times 6 minus y times y, or p is equal to 16 times 6y minus y squared. And then 6 times 16, I believe, is 96. So p is equal to 96y minus 16y squared. All right, so that is step 3. We've substituted the constraint into the objective function. So now we want to optimize the objective function. So what we've done so far is the new part. What we're going to do now, you already know how to do. So we are going to take this and we're going to find the derivative, p prime. P prime is equal to 96 minus 32y. And we then set the derivative equal to 0. 96 minus 32y. And so we're going to end up with 32y equals 96, or y is equal to 3. And so now we know what our y value is. That is the y value that will maximize this problem. To find the x value, all we have to do then is go back to purple. We know that x is equal to 6 minus y, and of course I got that from up here. And so then x is equal to 6 minus 3, so x is also equal to 3. So that is the x value that will maximize this problem. But to answer the question fully, there's 3 parts to the problem that you'll see in more. We also have to find out what is the maximum value of p. And so p is 16xy. We now know the x and the y value that will optimize the problem. All we have to do is substitute them in. So 16 times 3 times 3, and that would be 16 times 9. And so 16 times 9, I don't know my calculator, 6 times 9 is 54, 9, it's 144. And we are done. All right, so this is a simple, straightforward problem. It is not in the context of a word problem, but this is the general procedure that you will use for every single problem. Identify the objective function, that which you're trying to maximize or minimize. Identify the constraint. Substitute the constraint into the objective function, and then optimize. So looking at the first word problem, let's just kind of go through the steps here. For minimizing average cost. So gymnast clothing manufactures expensive hockey jerseys for sale to college bookstores in runs of up to 500. It costs in dollars for a run of X hockey jerseys is given by the function. So X is the quantity, the number of hockey jerseys. And so what we are given is a cost function, all right? How many jerseys should gymnasts produce per run in order to minimize average costs? So here's what we want to minimize, average cost. So that's my objective function, average cost. Now, be careful, we are given the cost function, we are not given the average cost function. So the first thing to do is determine the average cost function. And so remember, we find average cost by taking the cost function and dividing it by x. So when we do that, it actually will simplify to 2,000 divided by x plus 10 plus 0.2x. So all I did was divide each term by x. Identify the constraints. In this problem, the constraints are basically numbers. They're numerical. There's not an equation. This is one of the few problems where there isn't an actual equation for a constraint. And that is that the number of hockey jerseys can't be less than 0, can't be equal to 0. We're going to manufacture at least one. But 500 is the maximum. And so that's step 2. Since there is no actual constraint, we don't have to do step 3. We can go right into step 4, which is to optimize. So again, here is the objective function. And then here is the derivative of the objective function. And you can see by first writing it like this, and then taking the derivative of that, you will get this. And then finally, you set this equal to 0 and solve it for x. Now, some of these problems are going to be a little tricky with the algebra. but it's nothing that we cannot do. All right, so we find out that x is equal to plus or minus 100, but negative 100 doesn't make sense within the context of the problem, so we can ignore it. So our answer should be x equals 100. The only thing that we want to do is to make sure that it satisfies our problem by being a minimum value. Okay, a minimum value, not a maximum value. And so remember, we can use either the first derivative or the second derivative test to test for max or mins. In this problem, I used the second derivative test. So I found the second derivative of the average cost function, and I substituted in 100. Now, remember, when you're doing the second derivative test, you don't really care about what the number is. All you care is that it is positive. So because the second derivative at 100 is positive, that means that we have a minimum value. Okay, and so then to find the average cost, you simply substitute 100 into the average cost function, and you end up with $114 per jersey. So therefore, 100 jerseys must be produced in order to minimize average costs, which will be $50 per jersey. So there's usually at least 2 or 3 things you're looking for. What is the minimum value, and what value of X or Y are going to give you that minimum value? All right, well, that's going to be it for this video. I will probably make some more videos with some of the other examples and be posting them shortly. Bye-bye.